Hello and welcome to Eaton's latest Current Thinking broadcast, where industry experts share their insights on the hottest trends in the electrical industry. My name is Greta Foster, and I'm the product line manager for distributed energy resources and microgrids at Eaton. And I'm looking forward today to talking with you a bit about a topic that has people talking in the industry. And it's the opportunity for buildings to become energy prosumers, where they are both consumers of power and producers of power. So I'm joined by two power management industry experts from Eaton and Enel, and we're going to talk with them about their real world examples and insights around this topic. So with that, I'll ask our guests to introduce themselves, starting with Phil from Enel. Phil?
Thanks, Greta. Hi, everyone. My name is Phil Martin, and I am the Vice President and Head of Energy Storage at Enel in North America.
Hi, I'm Paul Connors, the Director of Marketing for Eaton's Electrical Engineering Services and Systems business. Within the services business of Eaton, we bring microgrids to life and deploy distributed energy resources. So look forward to the conversation.
Great. Welcome to both of you. We've got a lot of good stuff to cover today, so we're just going to dive right in. So again, the topic being the state of buildings as energy prosumers. So let's begin by laying out some of the concepts of what this really means and contributing to the idea of buildings being both energy consumers and producers of power. So Phil, what are some of the important things for people to understand about this space?
It's a great question. I would think about two important concepts in terms of this prosumer topic. The first is the rise of decentralized and distributed energy solutions that allow customers, commercial industrial customers, to produce and store their own power on site. And that's typically through solar photovoltaics plus a battery energy storage system, sometimes combined with other assets on site, sometimes in a microgrid. And that allows those consumers, particularly those focused on decarbonization or resiliency, to be producing and consuming power that they generate on site, often reducing their consumption and needs from the grid, sometimes entirely reducing. But typically, that would involve them consuming both from their on-site production as well as from the grid. I think the other important concept from the prosumer topic that maybe doesn't get enough focus is the fact that when you have these types of distributed projects on site, those projects, battery storage, microgrids, can also be producing services and providing services back to the grid. So it's not just a question of producing electricity and producing electricity in excess of what might be needed on site and exporting that back, but how we utilize and optimize those assets on site can provide important grid services back to the power grid as a whole. And actually, I'm sure we'll talk about this further, create revenue streams that can help fund these types of exciting projects.
Great. Now, Paul, maybe turning to you, can you comment on some of the benefits for buildings deploying such, solar and storage solutions?
Sure. Solar by its own is a intermittent resource, right? You can't always count on a sunny day here in the Pittsburgh area, but solar combined with storage, you can have even greater benefits whenever you're able to take the excess solar production and store it in the battery energy storage system for later use and optimization. The advantages to the prosumer are pretty straightforward. It's a combination of sustainability, right? Being able to reduce the dependency on fossil-based fuels. It is economic, right? Being able to offset costs of purchasing power from the grid. And then last, resiliency, right? Obviously having the ability to consume power generated locally and use that as backup power in the case of an outage. So.
Great. So with that background, maybe Phil, can you comment on why now? What are the innovations that have enabled these capabilities?
Like many things, it's a trend and not all of a sudden a particular inflection point. And I think there are a couple key trends to be aware of as we think about the increasing viability of these types of distributed energy projects that lead to buildings acting as prosumers. And The first is one that I think has gotten a lot of attention in the media, and that's just the falling cost curve of these technologies. We saw this with solar photovoltaics, where the decrease in those costs, in part because of just the increase in manufacturing capacity, led the cost of solar panels to exceed analyst expectations in terms of what that cost decrease, that cost curve would be. And we've seen something very similar in the case of energy storage. In the last just over 10 years, we've seen an almost 90% drop in the pack level lithium ion costs. And that's driven by technology improvements, but it's also driven by, again, manufacturing capacity, particularly with the rise of the electrification of the transportation sector. And as you reduce the cost of these upfront projects, it's just easier for them to pencil because of the lower capital costs. So that's one. The second piece, and I touched upon this a little while ago, is the fact that increasingly these types of assets are able to not just provide savings to the host site based on mitigating certain types of retail rate charges or producing power for a lower cost than is possible to consume from the grid when you include all the costs of transmission and distribution. But these assets can also provide services to the grid and be compensated for those. And that creates an important revenue stream that flows into these projects. And, Paul mentioned a minute ago about the intermittency that is associated with renewables. As we put more and more renewables on the grid, that creates a larger challenge and need for flexible capacity. And distributed technologies like microgrids, like energy storage, are great sources of flexible capacity, and they can be remunerated for providing that service to power markets and to grid operators. And so that's point two. So you've got lower costs. Now you've got increased revenues for these projects. And then number three, which again is a trend versus a discrete inflection point, is the rise of what's often called energy as a service, or certain types of structured finance models, where entities like Enel that specialize in designing and owning and operating these types of projects are willing to finance them on the basis of the savings and revenues that these projects can generate. And as a result, make available to customers these on-site solutions with no upfront capital cost, and instead be paid for the construction and operation through the ongoing financial benefits that these projects create over their 10, 15, 20, or 25-year lifespan. And when you take those together, you're now reducing the upfront costs, you're adding revenues into these projects, and now you're reducing the barriers to entry because you're avoiding the need for capital budgeting on the part of these potential hosts and customers as well.
Yeah. It's pretty exciting to see the convergence of all these capabilities and innovations. It's sort of like there's no better time, for some of this to come to fruition. So, Paul, with that background, maybe you can comment on some of the different use cases that we're seeing with buildings being energy prosumers.
Yeah, when it comes to the building, a lot of it's about the characteristics of that building and that consumer of power, and the use cases really, drive, what the right fit is. If I could go through a couple of the characteristics, you'll see what I mean. So, size and spend of a building owner's energy usage. So when you look at a building that is very power intensive, I characterize that as being, over a megawatt of average load and over 2 megawatts of, peak load. That's going to be a building that has significant power needs. Often that's going to be an industrial facility or a hospital or campus of some sort. And in those types of buildings, their energy bill is going to be over $50,000 a month, right? So that's one area that you would look at as a ripe opportunity for a distributed energy resource model. The other, when you look at the building owner, who is it? Do they have long-term objectives in mind? Are they a long-term tenant of the building? That's important to understand. and what are their sustainability objectives. So do they have public commitments to reduce their carbon footprint, or do they even have a net zero pledge? When I think of Eaton, in 2018, we announced a targeted 50% reduction in our greenhouse gas emissions by the year 2030. I'm sitting here in the headquarters in the greater Pittsburgh area. We have solar panels on our roof. Up the street at one of our manufacturing facilities, we have the largest solar array in Western Pennsylvania. So those things are both congruent with the fact that we have significant energy costs at these locations, but also those pledges towards sustainability. Some other characteristics I think about are buildings that have reliability concerns. Do you have power quality issues in the building or manufacturing facility? Do you have outages maybe more than once a year? Are you in a location that is maybe more susceptible to climate events, whether that's hurricanes, earthquakes, wildfires? We're finding these types of climate events, unfortunately, more common now than in the past. And then also just kind of point to the building's need for resiliency and what is the core mission of that facility. And if the owner of that building or facility can quantify, what resiliency means, that is really important. We've had a customer use case that came to us where it was a pharmaceutical manufacturer, and they lost a significant amount of money when power went out, and they had to start a batch of product over. So that's a very specific instance, but the ability to quantify the pain of an outage really helps emphasize the need for resiliency. And then last, what is the cost of power? So not just the total cost, but the per kilowatt basis. So I think of over 10 cents per kilowatt hour as maybe a benchmark for what might be a more expensive side of a bill. And then last, what regulatory incentives are there in the location of that building? So it's really multifactorial, right? And there's not any one characteristic that I just brought up that is the one thing that I would say will drive whether a distributed energy resource model is the most appropriate. But those are all considerations for whether the adoption of a renewable resource in conjunction with the utility feed makes sense for a site.
I just want to jump in on something that Paul mentioned there, which is in this kind of multi-factor equation of looking at the energy costs, but also Paul, you mentioned local regulatory support. Oftentimes we see the two of those come together, that the areas of the country that have some of the highest energy costs are also the areas that have some of the most robust support mechanisms for these types of technologies. And so there can really be this confluence of different factors that help lead to a business case.
Oh, that's great perspective. And I'd like to dig a little deeper into this, kind of use case and with transitioning to a project that you're currently working on together in Puerto Rico around a microgrid. And maybe, Paul, can you share with us sort of the business case that Eaton took to really stand up microgrids in Puerto Rico? Well, why did we move in that direction?
Yeah, absolutely. I referred to the headquarters location I'm in here and the manufacturing facility up the street in Western Pennsylvania. Those are both examples of where Eaton is really walking the talk on adoption of renewable resources. And, our manufacturing facilities in the Caribbean are yet another example. As many of us remember quite vividly, in the fall of 2017, a Category 5 hurricane swept across the Caribbean. And it was highly destructive to that area. Fortunately, Eaton's facility was built to withstand very severe conditions, but the local infrastructure was quite significantly damaged. And of course, not only does that mean potentially impact the reliability of power coming to our facility, but also the power of the homes of all of the workers. So it became evident to us that we needed to address our resiliency needs at that site, to make sure that we had an even more robust continuity plan in the event of a climate event like a hurricane. So, on top of that, when we looked at the bill we had for diesel fuel over the course of the many weeks and frankly months following that hurricane, it really was testament to the fact that this was an opportunity for Eaton to really help address our sustainability objectives. So, working with NLX together, we are deploying a microgrid at that facility. So, give you a sense of what we have going on there, but certainly encourage you to, take a look at, some of the material we have out on eaton.com/microgrid projects. At that site, we are deploying over 5 megawatts of solar at each site. With that combining 1.2 megawatts of battery energy storage, and then of course deploying the intelligent controls to make that system work together. We often call the intelligent controls the conductor of the distributed energy resource orchestra. So knowing when to take advantage of the solar production, when to pull from the battery energy storage based on maybe the state of charge of the battery, how expensive the power is coming off of the grid. That orchestration is very important, and the intelligent controls are the brains behind all of that. The system that we're deploying are going to absolutely provide the benefits I was referring to earlier relative to sustainability, economic, and of course, resiliency. The renewables we're deploying are going to account for over 50% of the daily power consumption at that site. We anticipate conservatively a 10% cost savings on our electric bill annually. And then it is, very much, in line with our sustainability objectives, with the reduction of over 4,500 metric tons of greenhouse gas emissions per year. So a project that we're really excited about, and again, one where Eaton is really kind of, walking the talk on our sustainability objectives.
Great. I also want to hear from you, Phil. How does this Puerto Rico project that you're working in partnership with Eaton on, what are some of the drivers behind that, and what does NLX bring to the table?
Sure. So, Paul mentioned a bunch of key drivers from the customer perspective, from Eaton, looking for that increased resiliency benefit, increased sustainability, and also cost savings. And the dynamics of the Puerto Rican electricity system really help us to achieve all of those. So, island grids in general have more expensive costs, and the power prices in those regions tends to be comparatively higher. And so, in mainland areas of the U.S. where on-site solar production can provide cost savings to grid prices, that's even more so the case in island environments like Puerto Rico, even when we have to construct the system to be able to withstand things like hurricane force winds and events. So, that's point one. What's also interesting is that in order to deploy a solar system of this size in Puerto Rico, coupling it with energy storage is actually a requirement that, Eaton would not have been able to deploy the solar in order to achieve some of these objectives without the storage, even outside of the need for and the desire for the system to operate in an islanding capacity to provide resilient backup power to the site when the grid is down. Certainly to achieve that objective, we certainly need the battery as well. But then, what Paul mentioned in terms of the orchestration between the microgrid controller, understanding when to consume on site, when to self-consume, when to use the battery to mitigate certain charges. The intelligent controls behind all of that are really essential to making this work in the real world. And what we saw from working together on this project, these two projects in Puerto Rico, is really the complementary nature of the two firms, where Eaton has a lot of expertise and experience around the power equipment, the engineering and design, the engineering services overall, and coupling that with the energy storage expertise from Enel, the project development capabilities, the project finance capabilities. What we were able to offer Eaton as a zero upfront cost project that is delivering, as Paul mentioned, 10+% annual bill savings. It became very clear in those conversations the exact type of solution that customers are asking Eaton for today, and how can we work together to broaden the scope of solutions that we can provide to the market, be responsive to customer needs and customer desires. And I think as we've started to work together outside of the Eaton footprint itself, we're seeing that partnership bear fruit.
Great. Okay, well, changing gears a bit, let's kind of continue the conversation to talk about the impact of all of this on the grid itself. So we talked about DERs previously. Paul, maybe can you talk about what the benefit of buildings becoming energy prosumers is for the grid? Why would a building customer want this capability?
Yeah, maybe before I talk about the prosumer, you mentioned grid. And I think there's a common myth out there, especially when I have these conversations, with some of Eaton's customers relative to the grid capacity. And when I ask people, what is your perception over the last several decades? Has the demand for power on the grid, reduced significantly, remained relatively stable, or increased significantly? And the myth tends to be that it has increased significantly, when the reality is that it's remained roughly stable. And so, based on that fact, the question becomes, why are we talking about this so much? And the answer to that is we're on the precipice of some major changes to the grid. And the electrification of transportation and buildings is the really a significant driver to that. So you can check out any of the outlets that you're accustomed to. All indications are that the adoption of electrical vehicles is going to dramatically change the grid and increase electricity demand. So wanted to first kind of address that myth, Greta, when it comes to the grid. And fundamentally, because of that increased demand that we all anticipate from electrification, we know that the grid of tomorrow will look significantly different than the grid of yesterday. So the grid of yesterday is very one-way flow of power, from a centralized power production to transmission, distribution, and consumption. And the grid of tomorrow, as we've been talking about, is really more about decentralization, right? Where you're going to have energy producing assets all across the grid, both at the front of the meter, at the utility level, whether that is utility scale solar or battery energy storage, wind, hydro, to behind the meter energy production. And of course, that's a lot of the focus of what we've been talking about with that building prosumer. The word that comes to my mind is flexibility. So when you have a lot of these different types of assets on the grid that are producing energy, you now need to have bidirectional flow of power, and you need to have the flexibility to call on the right energy producing asset at the right time, and the intelligence to control all of that. So for the prosumer, having that flexibility is key. And really, if you think about this in simple, supply and demand economics, competition is good. There's a lot of entities in the equation that are reevaluating their business model and their consumption model, and really it's leading to the democratization of energy production, and this is going to provide prosumers of energy with a lot more choice, and with that choice is going to come lower costs, and we've alluded to that earlier. I talked about the Puerto Rico plant with a 10% cost savings of deploying those renewable assets, and that same model will be important to other prosumers of energy as they look to take advantage of the benefits of renewable resources. So and of course, Phil, you've alluded to some of the revenue generating aspects of these assets, which of course brings in even more use cases for a building owner. So that's those are the key benefits to a building prosumer.
Great. So maybe taking the other side of things, Phil, can you comment on what the advantages of this capability for grid operators and utilities? Why would they want these services and products?
Yeah, so I mean, the way I would answer that question, Greta, is that what grid operators and utilities want is reliable, cost-effective, and sustainable power, but they're relatively agnostic about where it comes from and the type of asset. And that's by design for, Paul, a lot of the reasons that you mentioned. So if we look at wholesale power markets, where it's arguably the most democratized and there's the most level playing field between distributed assets and traditional fossil-based assets, those grid operators are responsible and regulated in order to ensure that they have security of supply and sufficient supply to meet demand needs, and then to also procure those supplies in a way that is going to lead to equitable and fair and cost-effective outcomes. And they don't individually procure certain types of resources. The independent system operators don't have a quota for a specific amount of a renewable power that they need to procure, or a specific amount of distributed power that they need to procure. They need certain product types, and they have competitive market and procurement mechanisms to procure those various solutions. So when you see a grid operator procuring distributed assets, behind the meter energy storage, load flexibility, the reason they're doing so is empirically because those solutions have been able to meet the requirements of the grid operator at a lower comparative cost than traditional solutions. Otherwise, they would not be procured. So, when you step back and recognize that, I think that's really instructive and demonstrates how far we are in this energy transition. That when you have a scenario where customers can procure energy, can procure energy that they're producing themselves on site that is cheaper, more sustainable, and more resilient, and at the same time, grid operators can be procuring either the output of those projects or the flexibility services that those projects can provide. And again, not because they're required to do so, but because they are empirically more cost effective. I think that helps us all acknowledge and understand where we are in this inflection point to energy transition, and really where these projects will start to really proliferate and create a virtuous cycle there. In terms of, though, to your point, Greta, on why grid operators would be interested in these types of projects providing services, I'd go back to a point that Paul mentioned earlier, which is the intermittency of renewables. And the more renewables that go on the grid, the more sources of flexibility that we need. Our grid of yesterday that Paul was referring to was really designed from this concept that there was only centralized power, and that centralized power production was very much on demand. It was fossil or thermal in nature. And that is not the situation that we have anymore. And fundamentally, from the perspective of a grid operator, again, their requirement is to ensure stability of supply, that the supply is there, and in real time it can provide the needs that are being demanded upon the system. And grid operators are constantly managing supply and demand to ensure that available supply can meet available demand. Because if available demand exceeds supply, that's what we call a brownout or a blackout. And historically, grid operators only had control of one side of that equation. All they could control was the supply side. But as we have more and more flexible resources, load flexibility, energy storage, microgrids, even electric vehicles, that creates another lever that grid operators can use to restore supply and demand balance. And at the end of the day, what matters is that equilibrium between supply and demand, not how the grid operators achieve that equilibrium. Added supply and reduced demand do the exact same thing. They create that supply and demand equilibrium in real time, which is what we all experience as reliable power. So I'd say that's the first point. The second piece that's unique about these types of projects, and why certain types of grid operators, in particular distribution utilities, see particular value in them compared to traditional sources. And that's it can be hard to build a power plant where you have the demand for power. Paul, you were mentioning how we're on the cusp of this dramatic increase in demand need that's fundamentally different from what we've seen over the last few decades. And if we think about what demand might look like in a urban area like New York City, driven by fleet electrification, well, it's relatively hard to put a power plant in New York City. In general, it's hard to permit and build large-scale projects like this. And the unique aspect of these distributed solutions is that there's an ability to site them exactly where utilities need it, where grid operators need it. And what we see from that is an ability to actually tap into additional revenue streams. There are utilities that are working with project developers and owners like Enel who say, I have a discrete need in this area. I need help deploying projects. And I actually am under regulatory incentives and structures where I would prefer to use a distributed project that reduces demand or can provide supply locally versus traditional historical approaches like multi-billion-dollar investments in substations or power plants. And that can create upfront opportunities that we can use to fund and make projects viable. But it also creates ongoing future benefits that even when we create a project today that might pencil on the basis of the cost of power and grid services that are available today, there's all this future optionality that we can tap into. And over time, I think we're relatively bullish on the fact that these types of projects are going to have increasing opportunities to provide services. They will have increasing value to grid operators, to utilities, to regulators. And that's why the way we structure our projects with our host customers is it allows them to share in that future upside because we're relatively confident that it's there. And we want to all be able to enjoy the benefits of that.
Yeah, Phil, your point there resonated with me relative to a recent conversation with a customer. And this is a customer in the Bay Area, and they moved into a campus setting that is kind of a retrofit to their operations. And they have significant growth objectives and significant power needs. And when they told their local utility that they were trying to grow to about 30 megawatts of power consumption over the next 5 years, and the utility told them they could only commit to expanding their capacity by 2 megawatts per year, they came to Eaton. and they said, what can you do to help me out, right? We absolutely know that this is going to entail the deployment of renewables. And that's where we got on site. We were looking at, the structural integrity of the roofs and how, what the building codes were and how well maintained they were. We're looking at the, techno-economic, analysis of what types of energy resources to deploy. Is there enough, parking lot room, to put solar canopies. In this case, it involved expanding some already existing fuel cells that were on the property. So, this is a trend that whatever direction you approach it from, whether you're the grid operator or the consumer, as you stated very nicely, that there is this mutual interest in reliable, efficient power.
There are clearly a lot of dynamics at play here, a lot of exciting changes in the industry, frankly, with the energy transition. And Paul, you essentially started to talk a little bit about this, but I'm curious if you can elaborate a bit about how Eaton and Enel are uniquely positioned to really help aid in the deployment of DER solutions, microgrids, et cetera, in these environments. Maybe you can continue to speak, and then we can hear from Phil.
Sure. I think Phil's going to talk about NLX's expertise in, what I call the market optimization, how to effectively participate in these, grid programs, and really their expertise and knowledge of the energy markets. From the Eaton perspective, Eaton is an intelligent power management company. So, the way that I translate that into this conversation is we are the experts in the site optimization. And that's our domain expertise, the safe and reliable and efficient use of power within the site. Eaton is often, that first device behind the utility meter within the building when you think about, circuit protection and power distribution. And really, that is where Eaton thrives. We are experts in the power distribution backbone. I've already talked about the intelligent controls. Maybe what I haven't touched on as much is our engineering services, the group that I represent. So, I essentially, talking about that customer example before, alluded to what we call a feasibility study. So it's going on to a site and understanding, what the needs are, what the current state of the facility, what available land might there be. So, those are all really important considerations to what type of model is appropriate for the site. Then, of course, it leads into the design, and that's where Eaton's engineering and services team can design and build in a turnkey fashion a distributed energy resource model. And then last, it's about the ongoing operations and maintenance. Something else our team provides. So when we look at this partnership, and whether it's the Puerto Rico example or a commercial or industrial building at one of our mutual customers, Eaton really brings a lot of expertise to the table relative to that site optimization and power distribution backbone.
Right. I mean, Paul, what you're just mentioning there around, the engineering services and that first device behind the meter. I mean, from the Enel perspective, that creates such a natural opportunity for partnership. When we are working to create one of these projects, the projects have to interface with the site, electrical design and system. And to be able to work with a company like Eaton that in many cases already has their hardware on site, may have actually been involved in the upfront design of that system in the first place. It's such a natural jumping off point for collaboration where we can then bring to the table the particular areas of our expertise. And so maybe just to build on what you mentioned, I think some of the unique attributes that we bring where we can help together with Eaton deploy these types of projects is number one, the software optimization and controls that, unlike a solar panel, which is a relatively passive asset, an energy storage system, a battery, really doesn't inherently create value on its own. It creates the optionality to create value based on how you decide to charge and discharge it. And the battery can do lots of different things. It can, reduce consumption from the grid. It can store power from on-site renewables. It can actually discharge. And in many cases, it is choosing which of those things to do in an individual moment in time when all of those are options on the table. And that's a really challenging and complex problem. There's a lot of discussion in the industry about value stacking or revenue stacking or application stacking, because this battery can do 6, 10, 15 different things. But it can't necessarily do all 15 of those things in a perfectly accretive way. There are trade-offs and there are opportunity costs. Sometimes when you do one application, you can't do another application. And that's a really complex multivariate optimization problem to solve. And we recognize that we're not smart enough to solve it in real time, but software is. And we have built an in-house platform that depends heavily on cutting edge, AI and machine learning technologies to forecast when buildings are going to consume power and how, forecast what's happening on the wholesale market side of things, and make those trade-offs in real time to maximize the financial benefit that can be created by these systems. And what's important to note is that those trade-offs can occur and accrue in different ways. Sometimes it might make more sense to pursue a revenue generation opportunity than to pursue bill savings, because the value of that revenue generation on the market side may be worth more than the bill savings. And for us, that's why we like to have commercial structures with customers where we're both equally exposed in that way and we have aligned incentives. By having a software platform in-house that's capable of doing both of those things, and the capabilities that we have in terms of market access really allows us to help make these types of projects pencil by taking advantage of these revenue generating opportunities from the market side, as you put it. And because we're confident in our own platform and our own ability to transact in these markets, we're able to underwrite and finance on the back of those types of expected revenues, which helps drive down the cost that customers experience, maybe not in terms of an upfront cost, but in terms of the ongoing savings that they're able to generate. And I think that's a really unique and important way in which we can help deploy these types of projects. But at the end of the day, the projects need to also be reliable, be designed in a way that meets site needs and site comfort levels, and being able to work with Eaton that has that area of expertise that in many cases has already been involved in that site and is a key stakeholder and trusted partner that helps overcome maybe not some of the economic barriers to projects, but some of the other types of behavioral barriers to projects that are equally critical objections and obstacles that need to be addressed in order to pursue and actually deploy these types of projects in the field.
Yeah. It's really great to see the teaming that is going on between Eaton and LX in these examples. So I'm excited to see where it's going to go as part of this energy transition. So kind of to bring things home, I wanted to just see if there were any final comments that you'd like to share on this topic that are really important for our viewers to understand. And maybe Paul, you can lead on this one first.
Sure, your comment there actually hits on one in my head, because we already touched on the fact that the grid of tomorrow will not look like the grid of the past. And the essence of an energy transition is that it won't happen overnight either. And so in my head, one of the key aspects to navigating this transition is partnerships. And so there is some sector coupling going on relative to power producers, hardware manufacturers, software developers and consumers of energy. And across that value stack, there is going to be a lot of partnering involved because there are mutually beneficial outcomes. So I think that's implicit to this conversation and Phil and I being on the phone here because we're absolutely living that in a major way. Maybe the two other points I'll mention are we touched lightly on the electrification of transportation, and that really is going to be a major catalyst. Okay, and when you think about how that adoption will evolve from maybe a couple to a handful of electrical vehicle chargers to dozens. That's also going to involve upgrades to the power distribution backbone of a site. And that's something that a lot of Eaton customers are grappling with right now and looking to us as domain experts in that power distribution backbone. And then, of course, you're not deploying a fleet of electrical vehicles so that you can burn more fossil fuels, right? So it's going to result in the faster adoption of renewable resources that is congruent with that mission of sustainability. So wanted to just emphasize, how important that is as a megatrend to everything that Phil and I have been talking about. And then last, the regulatory landscape. You will find that there might be experts in certain pockets and then regional experts, and of course it's evolving. And I'm thinking of a news release I saw just this week where the White House affirmed that they will not increase any tariffs on solar photovoltaics coming into the country. So things like that are important to keep your eye on. And of course, Eaton and NLX help our customers to navigate that. And I think looking to experts, looking to partners is a key part of demystifying this, because it's not necessarily mission critical to what a building owner does every day, and they're looking for that easy button, someone to come in and provide that expertise, and that'll be an important part of partnerships like Eaton and NLX have. So.
Dovetailing on what you were saying there, Paul, that's actually really similar to one of the points that I was going to highlight, which is this is a really dynamic environment. And it's, I think it would be a mistake to sit back and say, well, the cost of all these technologies keeps falling, so I'm just going to sit back and wait to do something, because the world, unfortunately, isn't that simple. And yes, the cost of solar panels have been declining on average year over year after the last couple of decades, but they might go up near term because of what you just mentioned. And understanding that complexity and how that can inform when and how you pursue a project, that's a full-time job. And that's not the full-time job of one person. That's a full-time job of a team and of companies. And that's why it's important that companies like NLX and Eaton are working together to be able to have that perspective and use that to help our customers make the right decisions. Similar example, energy storage costs, as I mentioned, they've been falling year over year for the last decade. They're actually not right now because demand is exceeding supply. And thinking about how those different elements come together is really important. The incentive landscape is changing. We might be seeing new tax credits for solar and storage, in the coming years. And there are lots of nuances to it. And it's candidly enough to make your head spin. My head is spinning every day trying to stay on top of all of these developments and making decisions. So I want to put that out there, that it can be sometimes tempting to oversimplify and just look at that cost curve, but the world isn't that simple. And it's really important to have these types of partnerships, because there can be real opportunities and real senses of urgency to pursue at projects at particular times, especially when we consider decarbonization, sustainability objectives and goals that companies have made, and just equipment lead times to get there. These are extraordinary times in terms of the overall energy transition, but also in terms of supply chain. And it's important to have that perspective. And, before I leave folks scared and concerned about that level of volatility and uncertainty, one thing that we haven't talked about with these projects that I think is a really important element of the value prop that's inherent in these types of energy as a service projects is just the budgetary certainty that comes with them. It's a really challenging time to be an energy manager, to be a CFO. And when you do these types of projects, a solar plus storage project or a microgrid that has a power purchase agreement or PPA component enables that host customer to lock in their power rate and have certainty on that power rate for the next 2 decades. And that's an important budget certainty element. That's an important cost hedging element. And so this is a complex and exciting time, but there are also some real win-wins here where customers can improve their sustainability, improve their resiliency, reduce their costs now, but also position themselves to best handle this dynamic and volatile environment that we're in long term. And I think it's really prudent for customers to be looking at these types of solutions now and at least placing certain bets or certain hedges that can at least de-risk some of what they're exposed to long term as we advance the energy transition.
This has been just really a great discussion. And I think you've given us all a lot to think about with these perspectives and the dynamics in the marketplace. So I just wanted to thank you both for taking the time to dive into this topic of buildings as energy prosumers and really touch on that energy transition element. It's, we're all facing, and it's an exciting time, honestly. So for our listeners, I just wanted to, give you an opportunity to also visit us at eaton.com/energy transition to learn more about our everything as a grid approach. And to thank you again for watching today. And I look forward to seeing you again on our next Current Thinking broadcast in the coming months. So thanks again, everyone, Paul and Phil, and we'll see you next time.
Thanks, Greg.
Thank you.